Use parentheses.
All right, so
I put like 45 parentheses in there.
So we took a break and calculated this function with these numbers in there. We got a weird negative thing in the beginning, and then it was close to 2, and then it got closer and closer to 2.5. So we're going to say 2.5. Or if you were doing this with your calculator and converted it to a fraction, it would give you 5 halves. And so I need you to write down 5 halves there. We're going to talk about that again in a minute.
So I did it.
So it says, graph the function in a graphing calculator using the following window. So I went ahead and put this in. So let me put my screen up. On my y equals menu, 5x squared minus 7x plus 1, 2x squared plus x plus 5. So we just put this function into the y equals, and then they're giving us what we need to set our window on to see whatever they want us to see. So
Your dad lesbian.
if we go to Mark, if we go to window and make these window settings 0 and 40 and go by tens, 0, 3, and they want us to go by 0.5s.
You went to window for that?
I went to window and just type all of these in.
Okay.
And then you can graph it, and it will allow us to see a little bit better what's happening. And these are going by 0.5. So this is 0.51, 1.52. And it says to use the trace. So what you can do for infinity is you can graph it, and you can trace out as far as it will let you trace. And so here I'm only getting to about 2.4. I think it'll let you go past the screen. It'll adjust. And so you can just keep going until your x is getting pretty large. And you'll see that this y value is still going up at a pretty good, not super fast, but pretty good. We're at 2.4, but it's getting bigger and bigger and bigger. And theoretically, if we did this long enough, we would see it approaching 2.5. I don't know that I feel like spending that much time on this, but if you keep going, if we keep going, okay, I'll keep going. So we're almost to 100 where we had 2.48. I'm not going all the way to 1,000.
We're at 2.4.
Why don't you just type in? Did we get our review today?
No. Well, maybe.
What are we doing?
You still have another IXL.
I have two.
Okay, so now we're at 2.45.
We're so close.
We are so close, but
0.05 away.
you guys are funny. Okay, so you keep going, and you'll see. I'm going to see if it'll let us put in 1,000 because that's off the screen, and it'll tell us no because it's not. The screen doesn't go that far, but you can trace over as far as you want. You could go into window and change the x values to go to 10,000. And then I think you would get there a little bit faster. I think that would be a better window. And you can hit trace when it's done. And then I'm already at 5,000, and you can see that it's 2.499. So I just made the x max a little bit larger. Cute. All right, so we're also seeing it's approaching 2.5, which if you converted would be 5 halves. So then there's a trick on method 3. Start with this original function. Divide the numerator and denominator by the highest power of x that occurs in the denominator. This is a weird thing, but it works, and it's actually kind of cool. So the highest power of x in the denominator is x squared. So I'm going to take 5x squared. I'm taking all of this and dividing by x squared, and all of this and dividing by x squared, which would leave me with 5 minus 7 over x plus 1 over x squared. And you're going, why is this helpful? You'll see in a second. And then it's over, and this would be 2 plus, this would just be 1 over x plus 5 over x squared. So they're using a principle here that basically says, remember at the top we had the limit. If you had x to any power in the denominator, it actually doesn't matter what number's in the numerator. If I take the limit as x goes to infinity, this gets infinitely small and this gets infinitely small, and that part goes away and the 5 stays. And these get infinitely small, and you're left with 5 halves. What? So that's a trick that is
I'm
algebraic,
about to drop some truth bombs, and
and that is the
I don't
end
know what happened.
of the lesson.